Page 18. I know this is part of your homework from last night. But are there any questions from page 18 you want me to go over, or page 17 you want me to go over with you?
Go.
Okay. All right, so number 11, this is bottom of page 18. This is which is an equation of the tangent line to the graph of the function where f prime of x equals 2. So we have to find our derivative, and then we can set equal to each other. So basically, we're just find f prime. We can go through power rule. So we go through power rule. X to the fourth becomes 4x cubed. 3x squared becomes 6x. And then 2 goes to 0. So remember, with the derivative function, there's one of two ways you can use it. So you can give it a location and ask for the slope, or you can ask for the slope. Give it slope and ask for the location. So in this case, we have the slope information. So let's plug that into here. So we know that 2 is equal to 4x cubed plus 6x. And we just basically have to find the x value here. Now, this is going to be tough to solve by hand. So I think what needs to be done, so I think one thing that we haven't gone through is how to solve this equation. Now, we can't really solve it. So what we can do is, I believe, so you can use your calculator to graph this function and look for the x-intercept. That's an easy way to look for an approximation. And then once we find the x-intercept, and also you can, another way is, I believe on the AP exam, you're going to have a link to Desmos. So you can also just put this in Desmos and just look for the x-intercept. And the x-intercept ended up being 1.678. So if we know that that the graph is going to cross through that x-intercept at 1.678. Wait, let me look here. Let me try it. 4x cubed. Sorry, I think ends up being sorry, 0.3. So it goes through this x value 0.3129. So there's a point here and 0.3129. X-intercept, not the y-intercept. And then the slope we know is 2. And then if we distribute that through, we'll get 2x minus still doesn't work out. 2x Okay, let me get back to you. I think this is the right way to do it, but for some reason, I'm not able to see how it matches with this answer choice here.
I think,
What did you do?
well, I think I put x back into f of x and then got 2.304, and then did point slope formula with that point. But then I got b. Oh, b's wrong.
So where f prime is equal to
Well, I got x equals negative 0.313, and then I put that into f of x and got 2.304, and then I just
did you get 0.3129?
Yeah.
Okay, and you plug this back into the original function.
Yeah.
Okay.
That's bad.
Sorry, this is a heavy calculator question here, which we haven't really had a chance to really work on. So. So I think this is the closest one I got. Is that what you got? 1.677.
You got 1.677.
Okay, so yeah, let me come back to this one and go through it more fully. This is more, yeah, this is one that requires a calculator in order to find that x value. But essentially, this is the starting point. The starting point is we know what the slope is, and we just find a location with that slope. So we set the derivative equal to the derivative. We set the derivative equal to 2, and then we algebraically find that x value, and then now it becomes an algebraic problem to locate a graph that goes through with that slope of 2. Okay, anything else? Page 17 or 18? All right, so page 19. So today we're talking about product rule and quotient rule. So this is where we're looking at if we have two different expressions that are being multiplied, can we still find a slope formula for an expression with that relationship? Or if I have two expressions that are divided by one another, can I find a slope formula that describes the behavior of that expression? Okay, so if I have an expression that's represented by f times g, usually these are two separate expressions in parentheses. The way that we can find the derivative of something with the setup, it's not quite as easy as just f prime times g prime. There's a little bit more to it, but we are going to multiply different combinations of f and g. So here's the relationship. If I want to find the derivative involving f times g, it's going to be f prime g plus f g prime. So we're basically taking the derivative of f and g and multiplying it with different variations of the other function. So it's going to be the derivative of the first function times the original second function. plus the original first function times the derivative of the second function. So if we look at number 1 here, find the derivative of each function. We can think of 8x as one term and sine x as the second term, because 8x is related. That's just a linear. Sine x is its own thing, which is trig. So I know this is called f of x, but when we call f and g, these are relating to the two different terms here. So if we call this f, and if we call this g, we're just going to go through and build out our derivative. So I'm going to label everything that we need to find. And then we're just going to ask what the derivative is, and then put it in its right place. So f prime is asking for 8x's derivative. So 8x becomes what? 8x becomes 8, okay? And then the original g function is just back to the original f function. 8x. And then g prime, which is asking for sine's derivative.
Cosine.
Positive cosine, yeah. Okay, so we put it together, 8 sine x plus 8x cosine x. All right, number 2. We can think of 2e to the x as the first term. The second term is root x, but if I want to get root x ready for power rule, I can rewrite it as what? Yeah. I'm just going to build out and label what I need to find, and I'm going to put them into my product rule formula. Okay, so f prime is asking for the derivative of e to the x. We know the 2 is just going to hang out in front. What's e to the x's derivative? Just e to the x. The original g function, no changes, so bring that down. Back to f, no changes, bring that down. And g prime, we go through power rule, so bring down the 1/2. And then what happens with the new exponent, with the 1/2? What does this become? Yeah, so we negative what? So what happens if we subtract 1 from 1/2? Negative 1/2, okay. As far as cleanup goes, just minimal cleanup. I think the only thing that I really want is make sure that your negative exponent is brought to a positive exponent. So right now, this is sitting in the numerator of this expression. You can push it down to the denominator. So here's what I have: 2e to the x times x to the 1/2. And here, the 2 and 1/2 becomes 1, so that cancels out. And I'm just going to put the x to the 1/2 in the denominator of this expression. So that x to the 1/2, or that x to the negative 1/2, comes down as x to the 1/2. You don't have to find a common denominator. I just want positive exponents in your final answer. All right, number 3, another opportunity for product rule, because we have 2 separate expressions being multiplied. Now, every term is pretty much ready for power rule within f and g, but there's something that we do need to rewrite. Yeah, needs to be rewritten as x to the negative 1. Okay, good. So I'm not going to start the derivative yet. I'm just going to rewrite it. Now, you don't have to do all this process of labeling everything. I'm just doing it so that for demonstration purposes, so that you can see exactly how each of the terms are fitting into product rule. But I won't take off points if you didn't have this included in your answer. I'm just doing it just so that it's clear where all the things are going. Hey, so f prime, x to -1, we do the derivative for that. So that becomes -1x to the -2. What happens to the 1? 0. Okay, so that drops out. Okay, g function, no changes. F, no changes. And then g prime, 2x squared minus 5 becomes 4x. As far as cleanup goes, we know all this is connected. I can push this x to the -2 to the denominator, or the -1 can go along with it too. So here I have 2x squared minus 5 or -x squared. I just want the negative exponent resolved. You can leave your answer unsimplified. This is fine. Okay, now we can also find a derivative using product rule when things are in function notation. So here we have a table that shows values of two differentiable functions. Again, differential means it's a smooth curve. That means the slope is able to be found at every point. There's no sudden sharp turn that we need to know about. So it's going to be a smooth curve all the way through. So again, yeah, anytime you see differentiable or twice differentiable, that just means smooth curve with no issues, no asymptotes, no holes, no sharp turns. Okay, so 3 f of x, g of x. We can go through product rule. Now, if you're thinking of this as, wait, doesn't this look like three things? Isn't this 3 and then f of x and g of x? Now, 3 is just a coefficient, so we can attach a 3 for the f or 3 to the g, but you just choose one. I like to just choose the one that is closest to, so I'll just let the 3 be part of the f. And then I'll let the g be on its own. So I'm going to build out the derivative first, and then I'm going to ask it for the slope. If we plug in to the derivative, we should be able to use all these values to help us convert all these notations back to numeric values. But first, let's build our derivative. So 3f of x, what do you think 3f of x could turn into if we want to leave this in function notation? F of x would just become what? It's going to stay in function notation. So what's the derivative notation for f of x? F prime, yeah. So we just say 3f prime of x. G of x stays. So we're just going to copy down whatever g is saying. And then back to f, no changes. And then g of x becomes what? G prime. So now we have a layout for our derivative function. Now we can find h prime of 2. So our next step, replace every x with 2. Oh, no, you're right. You're right. So my f is I had that as part of f, so that 3 needs to come back into my f. Thanks. Because I defined it that way, I need to put that. But if you had the 3 either outside or 3 with the g, then you have to distribute it through later on. But yeah, I need to have that 3 somewhere. Okay. Okay, questions so far? So now we can replace every of these values with what we have in our table. So f prime of 2, f prime of 2 is -2. G of 2 is -1. F of 2 is 4. And G prime of 2 is 2. Okay, so 2 negatives, I get positive. So I get 6 plus 24, which is 30. Okay, any questions? Yeah, I want to work number 5 on the separate sheet just so I can have enough so you can see all my work here. So here's number 5. Again, we have the ability to do product rule here because we have clearly 2 separate expressions that are being multiplied. So let's go through product rule. Now, as I rewrite this, sometimes, again, anytime we see a number below a value, it always feels more intimidating. Like it's like, oh, what do I do with that 2? Is there another way to rewrite this where it feels a little bit cleaner to look at? Yeah, you need to add that 1/2. Again, you don't have to move it. I just find that students just feel less stressed when they don't have to stare at a number below their variable. If it just comes out in front, it just looks like any other coefficient. So you can always do that. You can always get rid of a denominator numeric value by just pushing out in front as a fractional coefficient. All right. So what I have in brackets, those I'm going to assign as my f and g. And I'm just going to go through and build out my product rule. Okay, f prime. What's the derivative of 1/2 f of x? The 1/2 stays, right? And what does f become? F prime, yeah. So coefficients, if it's attached to a variable, it's just going to stay with the derivative of that variable. Now, if the 1/2 is by itself, if it's 1/2 plus f of x, then the 1/2 would completely go away. What happens to the 2? Goes away. Okay, so that's 0. I'm going to copy my g function over. Back to f. G prime, okay, the 3 goes to a 0. Minus g of x becomes, yeah, the negative stays, but g becomes g prime. Okay. So now I can replace every x with what? Good. Yeah. So now we're trying to get to the slope value of this function's derivative. So replace every x with -5. And then you're just going to, piece by piece, use the table of values to make your substitutions. Any questions?
When you do
Mhm.
1/2 times 3 plus 2,
Right, okay.
I got 7 over 2. But what? Because wouldn't there be 3 over 2 plus, and then 4 over 2 to have equal denominators?
Yeah, I can do it that way. And then multiply by
-5.
and 5.
35.
Which is the same thing as. Yeah, which is the same thing as this. So if I have -35/2, that's the same thing as that. And I would add 10 to it. And I'll get the same thing. So you're right. No, you're right. Okay, there's if this is on the AP exam, if it was true response, you could leave your answer like this, and that will be fine, as long as you've converted all of your numeric values to all of your function notation to numeric values. But I think it's good to practice to get to this point, because if there's multiple choice, then we definitely need to be able to merge these numbers together to get some variation of the answer choice. But any other questions here? So what I did here was that I distributed this through, and that's how I got those, but you could have combined this and then multiplied by -5. So, you guys are, perfectly fine by using different ways of cleaning up. Right, the rest of this page are just more practices for product rule, but let's make sure that we can go through quotient rule as well. So page 20. So quotient rule, if I have two expressions that are divided by one another, and I need to find, and I want to find the derivative of two expressions divided by one another, it's gonna, in a sense, it's gonna kind of look like product rule initially, but there's gonna be a denominator portion to it. So it's still gonna be f prime g and fg prime, but instead of a plus, we're gonna put a minus in between. And then here's the part that sometimes students forget about. There's also a divided by g squared. So it's going to be the original denominator squared. So if you can memorize, if you have product rules definition memorized, then you're just really using the same pattern for a quotient rule. Just make sure you put a minus, and don't forget there's a denominator g squared. All right, so number one, 2x squared over 3x plus 1. The numerator I'm going to assign as my f, and denominator I'm going to assign as my g. And yeah, usually I'll talk about a cleanup when we get to it. So y prime is equal to, let me label everything that I want to find. F prime g minus fg prime all over g squared. F prime becomes Mhm. Original g function, I'm just copying down my g function, no changes. Back to f, no changes. G prime, what's 3x plus 1's derivative? It's 3. All over my denominator squared, so 3x plus 1 quantity squared. Now, as far as cleanup goes, I think the most I'm going to ask you to clean up is the numerator. Careful with your quotient rule, your denominator. Typically, your denominator is not going to go anywhere. You don't have to FOIL out. You don't have to do anything. I think what I see some students do is they want to cancel stuff out. But remember, even though looks like it's being multiplied, this is still attached to a minus sign here. So we cannot cancel across addition or subtraction. Unless for some reason this whole thing wasn't here. If that whole expression wasn't there, then yes, everything here is being multiplied. We could cancel out. But usually with quotient rule, once you get your denominator to show up, you're not going to touch this anymore. The most that you're going to do usually is just with a numerator in terms of cleaning up. So let me just show that cleanup here. If I distribute that 4x through, and I get 6x squared plus 4x. And then usually your denominator is just not going to change. So I just want to show that if I actually clean up for quotient rule, you're just going to merge the numerator as much as you can, but denominator you leave alone. All right, number 2. Again, an opportunity for quotient rule, numerator and denominator divided by each other. Okay, what's 3e to the x's derivative? No changes, yeah. And then 2x becomes 2. And your denominator is just 2x quantity squared. X. Let's practice one in function notation. So let's try number 5. Actually, sorry. Let me change it. Let me try number. Let's do number 6. But this one feels a little bit backwards because we're used to calling the top f and the bottom g. I'm still going to call the top f and bottom g. Just know that the letter seems to be flip-flop because the numerator is g and my denominator includes f. I'm just going to follow my definition here. Oh, there's a negative in front. Sorry, I forgot to catch that. So usually if I see a negative in front, you either put it in numerator or denominator. But I'm just gonna put it in the numerator. So I'll just let the negative stay with my f. Okay, replace every x with 2. You guys get 8/9 or 4/9?
4/9.
4/9.
4/9. Oh. That's awkward.
Something.
When you bring down the negative from, like, it's like negative g of 2, since g of 2 is -1, and then there's another negative already in front of it. Plus the minus.
Right, so g of 2 is already -1, right? So that's positive times negative, which is really,
Yeah.
but this is a -2, right? Or positive 2.
Yeah, it's the positive because it's also the
Right.
It's also negative.
Yeah. So it's -2 then. Yeah, that's what I got, but I think I lost track of some of the negatives in between. Let me see. Page 19 to 20.
Is it?
They had a good eye.
Now, guys, homework, page 19 to 24. Of the remaining problems, just do the odd number problems. I'll send out a reminder this afternoon.
Did both pay? Yeah. You know, the problem. I mean, yeah. Oh my God, I'm so happy. You have it's not even shit. I haven't laughed.
I throw.
You don't have any.
You're nothing better than this. I'm glad. Great, you're calling down.
Exactly, bro, like that work, it's so easy. I finished in about 10 minutes. I think you said. Students give a lot of.
Have a great day, guys. See you tomorrow.
Yeah. I expect that it's a standard deviation.
Oh.
Have a good day.
Thank you. Have a good day. Appreciate it. Thanks, sir. Have a good day.
That's me. So are you? I messed up my signs on Wednesday. I messed up. I see what you mean. Yeah. Quotient will be. Yeah. I know. So you got. Quotient will be.